Hello everyone, this is another demo video on Anadez. In this video we're going to look at a liquid GC application. The previous video was about a vapor GC application. Here we have C5 plus product service with total C4 measurement. This is the composition given in weight%, and these are the tapping point parameters. Total C4s is the sum of all the components that have 4 carbon atoms in it. So let's start feeding the information. I'm selecting process C5 plus product service, and we have to select mass fraction or percentage here, as the composition has been specified in weight%. Okay, so I'm entering the first component, butene, and searching. And if you see the list of components here, there is no component as butene. If you go here, so there's no component as butene, so we have to select one butene here. And the composition value is 0.04. The next component is N-butane, and the value is 0.91. So both of the components got listed here. Similar to the previous video, I'm going to load a saved project to save time. Just to drive the point home, I'm going to reset this tool so that we could load the project afresh. So it throws up a dialog box saying it is recommended that you save the project before resetting. This will reset all the values and reinitialize the application. Any data entered by the user will be lost. Please click yes if you want to save your project, and no to reset Anadez. I'm going to click no as I want to reset. Well, everything got reset now. Now we could load our project, which has been saved earlier. This is the demo project, and all the components, all the data got imported into this tool now. Okay, and we have our analyte here. If you scroll down, total C4s, this is not present in the component database, so you will have to click on custom analyte and then enter the name of the analyte here. Okay, these are the ambient conditions, and I have considered Siemens Maxim 2 for this case, and the area class here, sample properties. You could see that the sample phase of tapping is liquid, and the transportation phase is also liquid. This is the molecular weight calculated, and the specified molecular weight is matching exactly with the calculated molecular weight, as there is no approximation here, unlike the previous case. Okay, this is density given, and these are the other properties. Probe details, we have these details here, and I've considered half-inch tube for this case, and it's acceptable. The design is acceptable. Distance and flow as per the specification here, 220 meter. I have considered 15 LPM as the bypass flow, and we'll come to that, why I selected that. This is bypass flow being returned to process, yes, and the return pressure, this return line distance, return line size, and this is the interface. So if I click on feasibility check, you could see that this is the chosen bypass flow, and these are the other results. Pump is required. Approximate lag time is 74. Fast loop pump skid required. Yes, delta P is this much. This is just an approximate information. So when we go to the transportation page, we'll get a better information. The primary sampling condition is required as we need fast loop pump skid, and this pressure is not very significant in the calculation because the calculation automatically takes care of the pressure. This pressure will indicate the bubble point here. I could explain that this way. If I just consider 14 here, the bubble point got changed to 156. So it will just help you get to know what the bubble point of this fluid is at this pressure. I'm setting it back to 18. I set 18 just because from the distance flow page and the feasibility check we know that this is the approximate delta P required, and we know the tapping point pressure is 5.01, so adding that we get around 17, about 17. So I've considered 18 here on this transportation page, and well, the sample pressure is 5.01 and the sample temperature is 110.1 degrees Celsius. If you go to the calculators and give the pressure 5.0 and calculate the dew point, you could see that the bubble point is 110.25 and the tapping point temperature was 110.1. This means that the fluid at tapping point is almost at a saturated liquid condition, and any increase in temperature will cause vapor formation, or any decrease in pressure also result in the same condition. So we have to use the fast loop pump skid and install it as close to the tapping point as possible. That's why I have considered 0.5 meter from the tapping to the fast loop pump skid, and the secondary transportation length gets automatically set as the balance. 20 meter is the total distance. Okay, so we have I have considered 10 as the